think that the Group 3 prepared just for you?
Ready to not just learn about science, but discover the story behind it, the elements.
Now, let's talk about the objectives. First is to explain the concept of the origin of the elements and describe how the universe began forming elements through major cosmic events such as the Big Bang, stellar, and supernova explosions. The second one is to identify and describe the processes involved in element formation, including the nucleosynthesis and the formation of atoms that became the building blocks of matter. The third one is to discuss the role of cosmological events such as the Big Bang, stellar, and supernova explosions in producing the various elements that exist in the universe today. The last one is to promote awareness and appreciation of how studying of the origin of the elements help us understand the universe, the beauty of science, and our connection to everything that exists. Now, we're gonna meet the guy who came up with this table 150 years ago. Like a lot of brilliant ideas in science, if Dimitri was alive today, he'd be around 155. He was born in 1834 in Siberia. The little Dimitri was the youngest of 13 or 14, no one's quite sure, and his mother came from a well-known family or a local merchant, and his father Dimitri was an educated man who was a teacher in a local school.
Chemistry. Chemistry is the branch of science that studies matter, what it is made of, how it changes, and how it behaves. It also helps us to understand the composition, structure, and properties of substances, and how they interact to form a new material. The father of chemistry. The first one is Antoine Lavoisier, from 1743 to 1794. He was known as the modern father of chemistry. His works laid the foundations for modern chemistry, especially in acids and chemical reactions. And he discovered elements named oxygen and hydrogen. The second one is Jabir Ibayan, or also known as Jabir. He was known as the father of early chemistry or alchemy. He lived around 8th century and was considered as the first true chemist. He introduced experimental techniques and invented many laboratories that is still used today. The third one, or the last one, is Robert Boyle, around 1627 to 1691. He was known as the modern father of experimental chemistry. He was the first to apply the scientific method to chemistry. He is famous for Boyle's law, which explained the relationships between the pressure and volume of gases. He helped to separate chemistry from alchemy and made it in a true science.
The origin of the elements refers to how different elements in the universe were formed. It explains when atoms came from and how they combine to create everything that exists, from stars, planets, and even living things. In simple terms, it's the story of how matter began. Through events like the Big Bang, star formation, and supernova explosions, new elements were created and spread throughout the universe.
The origin of the elements taught us a lot of things, not just about science but also about life. Have you ever wondered where everything around us really came from? The air we breathe, the water we drink, and even the stars that shine at night? All of those things, including us, are made of the elements.
And events that started in all the Big Bang Theory, which explained that the universe began. The Big Bang Theory states that around 13.8 billion years ago, the universe started from a single, extremely hot and dense point. Then, it suddenly expanded, creating space, time, and matter. As the universe expanded, it began to cool down. During the cooling process, the first simple elements such as hydrogen and helium were formed. These two elements became the foundation for creating stars and galaxies.
The Big Bang, another important event followed the formation of stars, where new elements were born. The universe was filled with gases, mostly hydrogen and helium. As time passed, these gases slowly came together because of gravity and started forming stars. Inside these stars, the temperature and pressure became very high. Because of these, new elements started to form. This is why stars are often called the factories of elements. They create elements that make up everything we see around us. These elements are very important because they are the same materials found in plants, animals, and even humans. But stars don't live forever.
The Big Bang shows how everything started from nothing. It reminds us that small beginnings can lead to something great. Stars live and die, but even in their death, they create life, just like supernovas from new elements.
The formation of deuterium. The collision of proton and neutron synthesize deuterium. It is an isotope of hydrogen.
The formation of tritium. The collision of deuterium and neutron synthesize tritium. It is an isotope of hydrogen.
The formation of helium. It is the second lightest element, and it is the collisions of tritium and proton synthesize helium. The formations of atoms. The formations of atoms is one of the most important parts in the origins of elements. Atoms are the smallest building blocks of matter. Everything around us is made up of atoms.
The periodic table of elements is one of the most iconic and recognizable scientific tool known worldwide for its ability to organize the known elements of the periodic. Periodic table is an arrangement of the chemical elements in a table format. The table is arranged into 18 groups and 7 periods. The elements are arranged based on their atomic number, electron configuration, and chemical properties. Elements on the left-hand side of the periodic table are generally metals, while the elements on the right-hand side are generally non-metals. In short, it is called the periodic table because of its repeating pattern.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, so we and organism, and then we're done.
Example is calcium. The atomic number is 20, then the atomic mass is 40. So the proton is 20, electron 20, then the atomic mass is 40 minus 20, then the final answer is 20. Example is medium. The atomic number is 37, the atomic mass is 85, then the proton is 37, electron 37, neutron is 85 minus 37, then the final answer is 48. Example is krypton. The atomic number is 36, then the atomic mass is 84, the proton is 36, electron 36, then the neutron is 84, minus 36 is equal to 48. Next example is antimony. The atomic number is 51, the atomic mass is 122, then the proton is 51, electron 51, neutron is 122, minus 51 is equal to 71.
Through this video presentation, we were able to learn not just only the origin of the elements, but also the teamwork and creativity.
In our video presentation, I learned that even the smallest particles can create something big and meaningful. In our video presentation, I learned that when stars die, they give life to new things, just like a new beginning.
In our video presentation, I've learned that the